Hey guys, what's up? It's Miss Cameron. Thanks for tuning in to another video with us Starbase staff. As you see, we still are teleworking, so we are still bringing you videos from home. We are going to try to do the best we can to get this content across as we are teaching you from our homes. So just bear with us. There will be a worksheet for this video as well. If you stay tuned throughout the video, I'll explain where you can find that at the end. And without further ado, I'm going to go ahead and get started. So today's topic is states of matter, and we have states of matter literally all around us. And so there's three types of states of matter that we're going to talk about today. So solid, we have some ice, liquids, which I have a liquid right here. I have some H2O, so I'll just pour that in there. Sorry if y'all can't see this. It is a one-man show for filming these videos, so I'm doing the best that I can. And then for gas, we have a balloon, and I will get to that here in just a second. Before we start talking about the characteristics of each of these things, I am going to talk a little bit about some terms that you need to know before diving into this lesson. So the first one I'm going to talk about is, what is mass? So mass is the amount of matter in an object. So basically it's the amount of stuff in it. So the amount of stuff in that object. So mass is a little bit different than weight. Okay, so weight is the amount of gravity's pull on you. So if we were to go to the moon, our mass would stay the same. We wouldn't be losing any fingers, toes, your belly button, anything like that, okay? What would change would be your weight, okay? So on the moon, we would weigh a lot less because there's little to no gravity on the moon, so we wouldn't have that pull. So that is mass and weight. The next term we're going to talk about is two types of energy. And if you saw our energy video, our energy explorations video with me and Miss Rocha, then you should have learned a little bit about potential and kinetic energy already. So we're just going to have a little bit of review on those. So the first thing we have is potential energy, and that is stored energy, and it's not moving, but it is capable of becoming active. So a good example of potential energy is, think about whenever you are sitting at the top of a roller coaster, right at the top of that hill. You're sitting there, you're not moving, you're wondering if the roller coaster is broken or if this is all part of the ride. Well, as you're sitting there, you have your maximum amount of potential energy, because as you start tipping down that hill, you're converting from potential energy to kinetic energy. And kinetic energy is the energy of motion. So as you're starting to progress down that hill and you're getting faster, 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 you think you're going to go right into the ground, and then you suddenly pull right up and you keep going on the roller coaster. You are using kinetic energy. That is the energy of motion, okay? So kinetic energy is used to change states of matter. So if you want to go from a solid to a liquid, you're going to have to increase the kinetic energy. And if you increase the heat that's being applied, you're also increasing kinetic energy that way as well. So those are a few terms for you. That one was kinetic energy. So the next thing we're going to talk about is each of these three things up here, each of these states of matter. So the first one we're going to talk about is solids. Okay, a couple characteristics of solids is they're tightly packed together, they vibrate against one another, they don't really move, okay, and it has a defined shape, okay? So if you look at the ice here, it's kind of packed in there. I move it, they're kind of just chilling, kind of just vibrating against one another. So this would be a good example of a solid. Also, ice is considered a solid, even though it does have the ability to melt, okay? So that was solid. The next thing we're going to talk about is liquids. So if you look at this visual, this picture right over here, the molecules aren't as close together as they were for the solids, okay? So with liquids, it doesn't have a defined shape. It takes the shape of its container. So as I poured this water into this glass, it took the shape of the glass. So if I were to pour it out, would it have the same shape of the glass still? No, it wouldn't. That water would go everywhere. And that is a good example of why those molecules kind of just move past one another. They kind of just wander off to wherever they please, okay? So that is a liquid. The next one we're going to talk about is a gas, okay? So the molecules in this box are well far apart compared to solids and liquids, okay? So these gases, they are moving, they're bumping against one another, they have all this open space, they take the shape of the container, okay? So those are just a few characteristics of a gas. All right, so the three states of matter that I have sitting in front of me right now, we have a solid, and that is ice. We have a liquid, water, and then we have a balloon. And you're saying, Miss Cameron, what are you gonna do with that balloon? Balloon is rubber, solid. Why do you have it sitting there? Well, if everyone will take a deep breath in, let it out. We just created a gas ourselves. We created CO2, carbon dioxide, okay? So what I'm gonna do is with the carbon dioxide I create, when I exhale, I'm gonna blow this balloon up to represent a gas. So I just created CO2 gas with my own body, and that is what is filling this balloon right now. So balloons are filled with helium, CO2 if you blew them up yourself, but that is just a good representation of a gas. For this first demonstration that I'm going to do for y'all, I am going to demonstrate kinetic and potential energy. So what I have here is I have a cold glass of water, kind of room temperature, kind of chilly, and then I have a warm glass of water, okay? So if you remember, states of matter need to change from one state of matter to another, you need to increase the kinetic energy and increase the heat. So I'm gonna grab my food coloring, and what I'm gonna do is I'm going to put a few drops in each of these, and I want you to watch the drops, and I want you to tell me which glass do they move faster in, which glass do they move slower in, and why, okay? So I'm gonna put this red folder up behind it just so y'all can kind of see a little bit better. So here we go. This is for the cold. All right, and then this is for the hot. Gonna let y'all observe for a couple seconds. All right, so I'm not sure if you can really tell, but in this glass, I can see the whole food coloring cloud just kind of moving about, just kind of chilling. So in the hot glass, I can see that the food coloring is quickly moving about, quickly for it being food coloring. And in the cold glass, I can see that it's just kind of slowly, lazily making its way down. You can still see that there is some clear right here, so it hasn't reached that part of the water. But it looks like in our hot glass that it has started to disperse evenly throughout. So what's going on is in the hot glass, you have a lot more kinetic energy and you have a lot more heat in the hot glass, which is causing all those food coloring particles to disperse. It's dispersed quickly, okay? And like I said, the more heat you apply, the faster those molecules are going to move. So when you look at the cold glass, it's not moving as quick and it's taking its time to get to the bottom. So this one has less kinetic energy than the warm glass. Okay, so this is something you can do at home, kind of observe yourself if you weren't able to see it very well here. So that was kinetic and potential energy. So this one has more potential energy than this one. Okay, so that one was the first demonstration. So what you're gonna need for this next demonstration is cornstarch. I'm sure you already know what I'm about to make. Water. A measuring cup. A container. And you don't have to use gloves, but Miss Cameron's gonna use gloves today, okay? So if you haven't guessed already, we are going to make oobleck. I want you to start kind of making your predictions in your head. Tell me, do you think oobleck is in solid, a liquid, a gas? What do you think? Okay, so I have my gloves on, and the first thing we need is 2 cups of cornstarch to 1 cup of water. So I'm gonna go ahead and pour my water. So I need 1 cup. Go ahead and pour my water in there. And then I need 2 cups of cornstarch. 1 cup. So I have my 1 cup of cornstarch in there. Here's my 2nd cup. And then just to kind of give it a little bit of color, I think I'm gonna put a couple drops of blue food coloring. Every video. I told you, Miss Cameron drops things. All right, so now you're just gonna give this a nice mixing. All right, guys, so I have made my oobleck. If you look closely, when you move it around, you're like, oh, that's a liquid, okay? Because it's kind of flowing, looks like a liquid, okay? But when you apply force, then it's not doing what we were just doing, okay? So again, when you move it around, it has the qualities of a liquid, looks like a liquid, kind of flowing past one another. But when we apply force, it acts as a solid. So what this is called is a non-Newtonian fluid. The more pressure you apply, the more it's going to act like a solid. But the less pressure you apply, so just doing that, it's kind of looking like a liquid. If you just gently tilt it, it's going to look like a liquid. So this is a non-Newtonian substance. So this isn't a liquid or a solid. Alright guys, so a couple announcements before I close this video out. Please remember to stay safe, wash your hands, wear a mask among this COVID-19 pandemic. Make sure you are doing your schoolwork. Also make sure you are watching out for our videos that come out Monday, Wednesday, and Friday. Mondays are usually kind of a lesson-oriented, more content-driven. Wednesdays are usually Wild Wednesdays with Mr. Maddox, where he takes you into his studio and shows you his animals or his plants, insects, things like that. And then Fridays are usually another kind of instructional video with different kinds of content. Like I said at the beginning of the video, we do have these worksheets that you can get at the link that we are putting into these videos. So it'll say you can get a worksheet here. This is where you can print one of these out and have your kids do them at home. Make sure you like and subscribe to our YouTube page. It is Starbase Goodfellow. And if you enjoy seeing these videos, let us know. We love making these for you guys. It is helping us to telework from home. We love that we're still able to telework from home and still bring you guys good instructional content. Without further ado, I think that is all that I have left today. So I hope you have learned something from this video. Let us know what you want to see later on. Maybe you have some suggestions as to what you want to see. And yeah, I think that is about it today. So thank you guys for watching, and we'll see you next time.